As we can see, lots of people have been a little bit tired after this very nice trip. And it was a very nice trip. And, but today and tomorrow is hard working days, and I'm talking a little bit about energy calculations. A little bit the same what have been Henrik have been doing 2 days ago, but I'm saying a little bit what we are doing in Estonia and which kind of situation we have, and how we can analyze more easiest way what is the consumption of energy of the buildings. And also I show you some calculation methods, and also not only this statical calculation method, also the simulation tool, and I show you what I have done with the simulation tools and which kind of possibilities we have with simulation tools. Also, after my presentation, you can discuss with this topic in your groups, and I can help you also in your group work to choose like heating or ventilation system, because I'm also doing in my home university these lectures about the heating and ventilation, and then you can ask these topics also from me. Okay. So, as we know that you have this retrofitting case, you have this Lithuanian building actually, and also one group is solving this Danish building. But this retrofitting case is always very difficult, because can we achieve this energy level with what we can achieve with new buildings? Mostly this answer is that we can't get the same level. And also we have the question about this design of the house, how we can design this house to look like better, but also maybe we destroy something, these design elements. And when we talking about retrofitting, we also want to save energy. But before we are going to start to insulate building, we must looking which situation is in place, and have this house some damages, and maybe before insulation we must fix these damages. And most important question is also about indoor climate. How we can achieve good indoor climate, and what is the situation, exact situation right now. Mostly in Estonia, we have this exact situation, like we have very poor indoor climate, and we have some damages inside of these block houses. Like same kind of houses we have, like this Lithuanian building a lot, and also we have made some research work about these block of houses, and the most thing is the damages is about moisture. That they have the condensation problems, they have lots of thermal breaches, or we say cold breaches because we have colder climate, but this is all these problems have been like this poor indoor climate together with this little bit high humidity level inside. And also we must fix this exact energy usage. How we can fix it? We can collect this energy usage data, and we can say that this is like heating energy, loses, this is electricity, and then we must make the heat balance, like how much heat we lose in some part of hoses, because this heating energy usage is the most important in Estonia. I was putting here some numbers inside, like this old block of houses. They have like for heating energy like 150 kilowatt hours per square meter per year. This is year actually. In Estonia we say this is aasta, but this is year. But when we want to renovate them, then we want to have this number, like 30 or 25, or what is your case? 2 days ago we discussed that it can be like for retrofitting houses to 25. Can be achieved? It is a hard question, because we must think where we have the losses of the house. We have energy losses from ventilation. This is one of the biggest part, because we must change the air for good indoor climate. When we have this natural ventilation, then this and we have like this air change rate is like 0.5 times per hour. The whole volume goes out. This whole volume air goes out, and this also of the volume comes in. This like cold, fresh air. Then we must heat it up, and it is very big consumption of energy. Also, this when we look at the house, the biggest part of this envelope area is external walls. And as you can see in Lithuanian house case, it is like 3 watt per square meter when the temperature difference is 1 degree. It's a lot. When we comparing it with new buildings, then it is like 0.15 or something. This is like 100 times more. It's a serious question. Also, the windows are the weak points of the house, because the old windows, we have single layer glass, like you have seen in Portugal, they have lots of single glass, but in Estonian climate we have 2-layer glass. Also in their own old apartment buildings we have this 2-layer glass, but this is like, this U value is like 3.0 or 2.7 something. But new glasses we can achieve like 0.75 or something. Also we have construction, exterior doors, roofs, basement floor, what we can also insulate in renovation case. Sometimes this engineer also forget that we have also the losses from thermal bridges and from infiltration. That when we are renovating, then we don't have any more this thermal bridges. But in retrofitting case, we can have the number of the losses smaller, but we can't have any of these. That means that this can't be zero. This cold bridges energy losses. I can show you this one case. Like when we are putting like 100 millimeters or a little bit more insulation on the external walls, then this cold bridges or thermal bridges conductivity we have like 2 times less, but we can't achieve this value 0. Okay, heat losses. I have put in here some calculations. I have said something about 2 days ago about this calculation for students who is making this calculation. When you need help with these values, then I can explain it later, but this is in my presentation and you can see it. But what is the meaning of these values is how we calculate this heating energy consumption. In Estonia we use like the simple calculation method is degree days method. That means that we have heat losses through envelopes, through ventilation, infiltration and cold breaches. This is like how many watts per temperature difference 1 Kelvin we lose from these heat losses. And we are counting this number together with this degree days, and we can have this yearly energy loss from building. It is very simple method, but how we can know how much degree days we have in the building, then we must know this balancing temperature. This is, we say it's also, this is like calculating indoor temperature. But what is the calculated indoor temperature? This is indoor temperature like 21 or 22 degrees minus temperature raise from heat gains. And heat gains from people, from electricity, and from sun, which is coming through the windows inside of the building. And when we have lots of indoor heat gains from sun and from people and from electricity, then this energy usage will be less. We can also calculate it, this with this Excel sheet what I have put in this useful materials, and I know that Estonians have also already calculated something with these Excel sheets. But how we can, in first level, how we can notice which can be this energy consumption of the house. In Estonian climate, we have this very simple graph which says that when we have this energy losses, like specific energy losses from envelopes, thermal bridges and infiltration, and we are comparing it with heated area, then we can have some number that this shows how many watts, like how many energy we lose when the temperature difference is 1 Kelvin per heated area. And then we can have like this number like 0.2 until 1.2 or something more. And then we can have this, we can realize which kind of energy, heating energy loss this house going to have. And we don't must calculate the exact values. But in this step we can make decisions. Maybe we should put more insulation for external walls and also dealing something with infiltration or cold breaches to achieve better value. So this is like for architectural students, it's very good to see which going to be this energy consumption after renovation to compare these values. Also, as I was saying that the U value is a very important question when we looking this heating energy losing from envelopes. And here is one graph which shows how much it would be when we have like 0.1 meter thermal insulation, and this black line is showing this concrete ball. And when this concrete ball we can see the U value here and this how much thermal insulation we have. Like when we have like 0.1 meter, then this U value will be like over the 0.25. But when we putting like 300 millimeters of thermal insulation, it would be like 0.40. It's very easy to understand with this graph which kind of values we can achieve. In Estonia, it was 1 year ago, the researchers have made some calculation for how to achieve this like low energy buildings and which kind of buildings can be like this nearly zero energy buildings. And these calculations are made for apartment buildings. And here we can see this value what I have shown you in this graph. This graph is this, that how much energy we lose from envelopes, from thermal bridges and infiltration per heated area. And this number can be like 0.2 until 1 or a little bit more. And these values are in the first row. We can see this is like this building below, this like this regular building, but they are building in Estonia right now. And the last is like this like nearly zero energy building. And between buildings are like this low energy buildings, you can say. And here you can see these areas of the envelopes and also this information about ventilation, windows and infiltration, and you can compare these values. And also when you are making the group work, you can look from this sheet which can be also included in your solutions. Like when we have this regular new building, then we can see this external wall U value is like 0.23, but it's like nearly zero energy buildings U value, external wall U value is 0.1, and so on. And this is like windows. The regular house we have this is the description of the window, which kind of window we have is 4 millimeter glass. The 16 millimeters are gone inside, and this is one reflecting glass outside, and this U value can be like 1.2. This is the glass, and this is the frame value. And also you can see which kind of glass we can use when we want to have this, to achieve this like nearly zero energy building. And after the calculations, these calculations have made with the simulation program, and I think that these are made correctly, because two professors have made it. But here we can see which can be this like space heating energy consumption for this regular buildings is 28.4 kilowatt hours per square meter per year, and this low energy, nearly zero energy buildings, it would be like 7.1. But we can also see from here that when we have this regular building or this low energy building, we don't have much for cool down these areas. But when we have this like near zero energy buildings, we must cool more in space. This is like 11.3 kilowatt hour per square meter per year. We must cool down this area, because in Estonian law says that this temperature can be raised upper than 27 degrees, only it can be rise about 150 hours above this 27 degree. Now I can show you one simulation what I have made by myself with this same simulation tool what they have. Use it in this research case. I hope that this building looks like this Lithuanian building a little bit, but it have 4 staircases, and in this picture actually we can see these overheating hours. This calculation have already made, and here is no cooling energy. And when we don't use this cooling energy, this building have like it have big window areas. This is one question why this temperature will be rise up to 27 degrees, like 1,800 hours, because it have big windows. This house have been, I have put it outside like 300 millimeters extra thermal insulation, and also up to floor, up to roof, also 300 millimeters of thermal insulation. This glasses, I can show you this U values from here. No, this is 150 millimeters of the extra insulation. This U value is 0.2, but this glass is this G factor is 0.56, what is a little bit too big when we are seeing this case. Here it's like it must be like 0.46 or a little bit less, because when it's bigger, then this solar heat coming easily inside, and we have this overheating problems. Also, when you are making this renovation case, you must think about how we can achieve this, that we must cool down these areas after renovation, because this is the big problem. In Estonia we say when we are investing for heating houses, then we must put like €1. But when we want to cool down, then we put like 3 or 4 euros for system. And it's a big amount of money. Okay. And with this simulation tool, we can also simulate the whole this period, and we can see when this spaces are overheated. And also we can see with the simulation tool how we can put some shadings here, and how it works in the building. In your case, you don't make the simulation, but you must think that this can be overheating problems when you don't include this shading question. And that is why I'm showing you this simulation tool, and show you this example, which kind of problems it can be had. In this case, I can show you this delivered energy sheet, and it's not this low energy building or this nearly zero energy building, but this maybe I can show you. No, I can't. Don't zoom it. But this heating energy consumption per heating area, it's 40 in this case. And as I said, that I haven't put it in any cooling energy, but this case was like that, that I want to see which kind of situation is then when I don't put any cooling devices. With this degree days method, we can't calculate this cooling energy need, and then we can have like this path of the roof of the building, and this is one little problem. But when we see that the main question in the houses or apartment buildings is the heating energy, then just you must also design some shadings there, that you must know that also in Estonia and in Lithuania we have this overheating problem in the summertime. When we looking at this export and import energy, then what we can do with the houses, which kind of primary energy we can use the houses, and how we can achieve this energy certificate that it shows that we can be under them like 100 kilowatt hours per year with all this energy consumption together, like heating energy consumption and also electricity consumption. And we can have like solar panels for the houses. We can produce electricity and export it, but is it a good solution in Nordic countries? I think this exact situation in Nordic countries, it's not very, it's not very valuable, or because this payback time is a little bit too long. I think it can't be payback anyway. But when the government support to buy some solar PV collectors or these kind of things, like half of the money we give you, then it's useful. But in Estonia we have research that this thermal solar collector is useful in our climate. When it's possible to, in summertime, we can produce all of this hot water energy from this thermal solar panels. And also, when it's possible, we can also export when it's possible. It depends on when we have this district heat, then we must have the contract with the district heating company, how we can sell it back or give it this free energy to another building. In buildings, how we can heat up this building, it's for dwellings. It's in Estonia we have this district heat system, and it's also this government supported that we have all the buildings have this district heat, and when we are counting this primary energy for energy certificate, then we have this calculated values is 0.9. That this is like more proving this energy certificate. But when we are looking for how we can achieve the better values, then we can use like this ground source heat pump or this kind of things, that we can use like 1 kilowatt hour electricity to have like 4 kilowatt hours heating energy. But this electricity counting factor is 2 in Estonia. This electricity is not very supported by government, that we are using electricity to direct heating primary energy. little bit said something about the 3 days method. When you are using this, I'm glad to help you. And also, I have some useful information in my presentation. And I have a little bit saying something about what is the 3 days and what is the balance temperature. But inside of my Excel sheet, when you are using this, this is climate data, and this balancing temperature is inside of this Excel sheet. You can find from this Excel sheet some examples for Estonian case, which kind of situation we have, like this example situation after renovation and what have been before renovation, like this heating energy need was like 152 before renovation, and when we are changing the U values, and also we can get back to this heat from exhaust air, then it can be like 26.3. But I think in the Estonian case, it's very hard to achieve better value. But thank you, and that was all that I wanted to say.